So the extraneous solutions are just solutions that develop through that squaring process. And they're going to occur all the time in this course. We do a lot of the that squaring procedure to alter equations throughout the year. And it's going to be something that's common for a lot of the things we do. It's going to be common when we get to trigonometry as well. There's a lot of times where we get solutions that do not work. We have to check them. Okay? So keep that in mind as you're going through. What I really want to focus on, though, and what becomes something that is very problematic for people, is when we have equations of quadratic type. Okay? Quadratic type we know to be ax squared plus bx to the first plus c equals 0, right? Okay? When we have equations, they might not always have a power of 2 and a power of 1. Okay? It might be a power of 6 and a power of 3. It might be a power of 12 and a power of 6. Okay? It might be a power of 1/3 and a power of 1/6. Okay? But if you think about all those powers I just said and where I was putting them, this one, if this power is always double that one, and this is a constant. Okay? So if this power is always twice as big as that power, then you have something that's of quadratic form. And you can use all our quadratic equation techniques to solve it. Okay? So we get to some functions that are, or not functions, equations, that are maybe challenging or daunting at first sight. So for instance, x to the 4th minus 8x squared plus 8 equals 0. Okay? It's not a true quadratic equation, right? Quadratic is ax squared plus bx plus c, and this is starting off as a 4th degree polynomial, okay, a 4th degree equation. So it's not quadratic, but it has quadratic form because of how the exponents relate to one another, and the fact that that b term's exponent is half of this one. So what we can do is we can rewrite this and get a red marker so you see this a little better. If I write those exponents in red, try to follow along with what I'm going to do here. I'm going to rewrite this as x squared squared. I'm going to rewrite this as minus 8x to the first, and then plus 8 equals 0. Okay? And hopefully you realize then what I've done is normally that variable right there and its coefficient is really a to the x, or a times x to the first power squared, right? Okay? Now I'm just rewriting it as a times x squared squared. But that power there and that power there are consistent. They're both squared. Same idea here, that power and that power are consistent. Most people are going to say, well, why did you do that? You don't really change anything here, right? It just makes things a little bit easier visually to realize that this is, in fact, quadratic form. So if I can manipulate my exponents and rewrite them so I can get a 2 and a 1, okay, I should have something that's in quadratic form. All right. Now here's where I'm going to give you 2 techniques for doing this. I think the first one is a pain in the butt, but it might help somebody. Okay. Normally, if this was just x squared, okay, you would probably use a quadratic formula here, right? If it was just x squared, your quadratic formula is equal to x, correct? But now it's x squared squared. Okay? So whatever this term is here is what your quadratic formula is actually equal to. So I'm going to go opposite of b, plus or minus b squared minus 4ac all over 2a. Okay? And normally, if that was just x to the second power, I'd write x equals that stuff, right? But now it's x squared to the second power, so this becomes x squared. Is that doable? Alright. After that, it's all the same as what we've done. Okay? I'm going to take the opposite of b, so what's the opposite of b here? And the negative is a portion of this. So be positive 8, right? So we get 8 plus or minus, okay? B squared is 64. 4ac, okay, you guys can double check me, but it's pretty sure it's 32. And then all over 2a. Okay? That's going to give me 8 plus or minus radical 32 over 2. What is a perfect square that divides 32? It's the largest perfect square that goes into 32. 16. So I'm going to divide 16 out of there. Gives me 8 plus or minus 4 radical 2 over 2. I apologize, I'm running out of room here before we go up. Will that 2 go into that 8? Will it go into that 4? So I'm going to divide those out. Gives me 4 plus or minus. Divide them out here. 2 radical 2. Okay? And that's my solution. And normally, the way we've been doing this is the solution for x normally, right? Because that's what the quadratic formula is set up for. But we've altered it a little bit, and that is now the solution for x squared. Okay? Now, generally speaking, we never really want to know what x squared is, right? We want to know what x itself is. You need a tissue. We want to know what x is, not x squared. So how do I solve this for x then? Yeah, take square root. Okay? I'll take square root here, take square root there. So x is, now we take square root, how many solutions do you really get? 2. So we have plus or minus 4 plus or minus 2 radical 2. Okay? What I need you guys to understand is there are 4 solutions there. Okay? 4 solutions. Because we're going to say the positive version of radical 4 plus 2 radical 2. And then we're going to say the positive version of 4, the square root of 4 minus 2 radical 2. And then we're going to say the opposite of the square root of 4 plus 2 radical 2. And then the opposite of 4 minus 2 radical 2. Does that kind of make sense? Okay? So you got a plus or minus here, you got a plus or minus there. 2 times 2 is 4, so you got 4 solutions. And that's what we're seeing here. They write them all the way out in your PowerPoint. But that's as far as we can simplify those. We don't simplify those any further other than changing the decimal approximations. But those are referred to, when you have a radical inside a radical, it's referred to a lot of times as a nested radical. Okay? When you have parentheses inside parentheses inside parentheses, a lot of times referred to them as nested parentheses, right? Okay? Think about a nest. Don't things live inside a nest? Okay? So we got radicals living inside radicals. We call those nested radicals. Okay? But you got 4 solutions there, right? Now, I don't like that technique. Okay? And you're going to see here in a little bit maybe a problem where we don't necessarily have to use the quadratic formula. And that technique can get kind of fuzzy, and I just don't like it. Okay? If you want to use it, but the one I'm going to use in class is going to be a little bit different. I'm going to rewrite that. I'm going to do the same problem, x to the 4th. Was it minus 8x squared plus 8 equals 0, right? Alright, so here's what I do. And again, if you want to use the old technique, that's fine. And if you do a question, you have a question in class, and you're using the old technique or the other technique, and you want me to do it that way, let me know. I can do it that way. If you're working with me one-on-one, make sure that I'm doing things the way you do them, right? I want to tailor it to you. This is what I think is very useful for some people. If we recognize that these 2 exponents are halves of one another, what I'm going to do is I'm going to look at this term right there. I'm going to introduce a new variable. I'm going to introduce the variable u, and I'm going to define it to be that middle variable, that variable term x squared. I don't care about the I don't want to change the coefficient. You could at some point if you wanted to. But I'm just going to interchange the x squared with u. Okay? So now think about what that does for us. X squared is x to the 4th, right? Okay? So previously we had x squared squared. Well now, if x squared is u, I make that substitution, and I just have u squared. Minus 8u plus 8 equals 0. Does that look like a lot friendlier than maybe that looks? Okay? I mean, that's Algebra 1 stuff there, right? Okay? So if we go through Algebra 1 stuff and we use the quadratic formula. Remember, the quadratic formula is solve for the variable that you're using, so I'm using u now. We go 8 plus or minus, so it'll be 32 on here, on the inside again, and that's what my discriminant's going to be. And then over 2a. Well, now I have u is equal to what ends up being, that's going to be the same 16 can come out, so eventually it's going to be 4 plus or minus 2 radical 2 again. But that's solving for u, right? So once I get down to u, and I've solved for my u that I introduced, I'm now going to do what we call back substituting. I'm going to replace, I'm going to go back to what they should have really been initially. And u initially was x squared, right? And now can you solve that equation for x? Square root both sides, and you've got x. Okay? You're doing the same thing, it's the same exact algebra. I just think it's a little bit more convenient approach and convenient notation to use. We call that u substitution. You're going to use that a lot, especially if you plan on going to calculus course. U substitution becomes a pretty important procedure when you do integrals. Okay, and it's just the whole purpose of it is to introduce something new, introduce a new variable that makes the algebra look like something you've done in the past, right? It makes this turn into something a lot simpler. Okay, solve it with that new variable, and then when you solve for that new variable, you can go back and replace. Okay, we'll even do a little bit of that in trig this year. It's very beneficial. I'll do another question. Let's do one we can. I think this one's kind of ugly. Okay. If we look at that, 1 plus 1 over x squared minus 6 times 1 plus 1 over x plus 8 equals 0. It looks challenging, right? It's got a really, really ugly variable term. Okay? So you could do this. You could say, well, I'm going to let 1 plus 1 over m, use the quadratic formula, with my a of 1, my b of negative 6, and my c of 8. And I'm going to plug my quadratic formula in, but know that my variable term is equal to 1 plus 1 over x. So a lot of people are going to say, well, I'm going to have 1 plus 1 over x is equal to then my quadratic formula, right? Okay? I think that's kind of ugly, and some people struggle with that, so this is kind of the best thing I think to do. Introduce u. Make it look simple. Okay? I let u be 1 plus 1 over x. Because then when I substitute u in there, I get u squared. When I substitute u in there, I get negative 6u plus 8 is equal to 0. Is that a lot more comfortable looking at than what we started with? Okay. A lot of people might look at this right away and say, it just scares me, I'm not going to do it at all. Okay. But if you make that quick substitution, now you get down to 9th grade math. Okay. So we're going to factor that. So it becomes u minus 4, u minus 2. So u is equal to 4 and u is equal to 2, right? The only thing you got to be cautious of is realize what you did at the beginning and how that impacts your results. You just solved for u. They want you to solve for x. So now I'll take that u and replace it with 1 plus 1 over x is equal to 4. And this 1 plus 1 over x is equal to 2. Subtract 1 from both sides, so we get 1 over x is equal to 3. And I don't really care how you do this, but this is really saying that when I say 1 over x, that's kind of the way we define a reciprocal. They're asking basically what's the reciprocal of 3? 1/3. Okay? Now you could have multiplied both sides by x and got something like that, right? And then divide both sides by 3 and you get your x to be 1/3. Okay? Here I subtract 1. if 1 over x is equal to 1, so what's x got to be there? That's a little bit easier. X just got to be 1. Okay. It's always a good idea to verify your solutions. Okay, let's see if this does it for us. Okay. So we do get the 1/3 and the 1. And because we didn't square anything or anything crazy like that, we don't necessarily need to check to see if both of them work, but it is a good idea just to get in that habit. Plug 1 back in. 1 plus 1 squared is 4 minus 6 times what? 2, so 12. So 4 minus 12 plus 8 does give me 0. Negative 8 plus 8 gives me 0. Okay? And then do the same thing with 1/3. Just to check to make sure you get used to that substitute. Okay? Is that something we can do? Alright. Now the next one's a little bit harder. The next one we're going to have to check our answers because of how we start using powers here. We get x to the 1/3 plus x to the 1/6 minus 2. X to the 1/3 plus x to the 1/6 minus 2 is equal to 0. It's an ugly equation, and it's not polynomial. Remember yesterday we talked about polynomials having the exponents had to be integers, right? Positive integers. Okay. Here we get rational exponents. Okay, so it's kind of ugly in that nature. But what we want to do is recognize that this is still half of that, isn't it? Still quadratic form. Okay. So what I always suggest doing is letting your u that you're going to introduce be that variable. So if u, or variable term, okay, without the, I guess I won't say variable term because when I say variable term, I'm saying that I should incorporate the coefficient. I just want the variable and the exponent that's raised to. That's what I'm going to let u be, right? Okay. Because now, when I rewrite and square this x to the 1/6 squared, does that give me x to the 1/3? Okay. So then that tells me if I squared that side, square that side. So that would give me u squared is equal to x to the 1/3. So I'm going to replace this thing with u squared then. Okay. If you recognize that you have that exponent being half of that one, you can always let u be that variable and that exponent. And then your first term will always be u squared. Does that make sense? Okay. It's kind of just a pattern every time that you come across these that you can do that. Okay. So now it's going to be u squared plus then u minus 2 equals 0. Down to something that's a lot simpler, right? After that, u plus 2 minus 1. And then u is equal to negative 2, and u is equal to positive 1. But remember, u was what? Yep, x to the 1/6. We got it. Come back in and replace. Okay. And at this stage, we have to realize that we're solving for x. And right now, it's x to the 1/6. So we're going to, and it's an equation still. Okay, this is still an equation, right? Very trivial, simple equation. But you're going to raise it to an exponent, right? So when you raise this to an exponent, whatever that, 1/6 to the 6th, okay, that's going to give me x to the 1st, right? Gives me x to the 6 over 6, which is x to the 1st. That's going to give me x negative 2 raised to the 6th power is a positive 64. I'll come over here and do the same thing. It's a positive 1. Okay? But when we square something, cube something, raise it to the 4th, 5th, 6th power, we are doing algebra that's going to create potentially extraneous solutions. So now that you have those two solutions, what you want to do, a couple different ways you can do it. I think maybe one of the easier ways is to go to y equals and type in my equation. X to the 1/3. This is going to save you time in checking both answers pretty quickly. X to the 1/3 plus X to the 1/6. Sure you got your exponent there. And when you're typing in fractions, rational exponents, make sure you put them in parentheses. It's going to save you a lot of heartache later on. And then -2. Let me... Come on. So we're typing our original equation in. Okay? And now I'm just going to go to my table set. I'm going to go down to the independent variable, which is your x variable. I'm going to ask the values. And I'm going to go to my table. And now I'm going to try 64 as the next value. And the hope is when I plug 64 in here, plug it in there, I should get 0 back. If it's a solution, I should get 0 back, right? I plug it in and I get 4 back. So what I just did is I just came up with this side to be 4. The right-hand side is 0. Is that a true or false statement? False. So 64 is not an answer. Okay? 1 then is going to be the next one I check. And I do get 0 back. Okay? So when I plug 1 in here, 1 in there, 1 in here, 1 in there, subtract 2 from it. 1 plus 1 minus 2 is 0. 0 equals 0. So that is my solution. And we're done. Does that make sense? I think though, hopefully you guys start to use your calculators in a beneficial way to kind of maybe use that substitution, get through that substitution quick. Look at your homework tonight, try it over the weekend, but it's not going to be due till Tuesday. But I want you guys to ask questions about some of those equations on Monday. See you, Zach. Good luck tonight.
Thank you.